Hello and a very warm welcome to you. This video is the short version of a much longer video that I'll be posting in response to Gleam. Gleam has produced some time ago a drawing in which he claimed to be able to explain the observation in this photograph in terms of a flat Earth. Now, anybody who's watched my channel will know that this and several other observations I've made prove that the Earth cannot possibly be flat. And the reason for that is that I was on Traprane Law at 221 meters with a camera looking zoomed in and looking past the Hope to Monument here, 8.2 or 8.3 kilometers away at 210 meters at the top, towards Ben Lomond, Ben Narnain and Ben Eam in the far distance. And because the camera is at 221 meters and the monument is at 210 meters, I'm looking at a slightly downwards angle. It means that anything that appears below this line must be lower than 210 meters above sea level if the Earth is flat. And anything that's taller than 210 meters above sea level must appear, a significant portion of it must appear above that line. And Ben Lomond, Ben Narnain and Ben Eam all appear completely below the line, even though they are approaching 1,000 meters, in the case of Ben Eam, over 1,000 meters above sea level. So 800 plus meters of Ben Eam should appear above this line, and in fact the peak of Ben Eam is around about here, well below the line. This is impossible on a flat Earth, but perfectly in keeping with globe Earth predictions. However, Gleam thought that he could explain this, so Earth is still not flat. And I toyed with some titles for this video. Gleam can't kilometer, for one. In the end, I've settled on why I can't take Gleam seriously. And the reason is that this is Gleam's drawing in an attempt to explain my observation. And this was the subject of a video that I made recently. And Gleam has responded in the comments section of that video. And the long version of this video will deal with the whole of Gleam's comment. His comment is in black and my responses are in red here. But for this short version, I simply want to concentrate on the picture because that actually is the topic of the video, my video, and is the only thing that matters, is Gleam's attempt to explain in terms of a flat Earth the observation that I've made. So Gleam's point number 6 in his response said at 1520 in my video, I say, he's quoting me here, let's see if we can figure out the percentage and scale. Because Gleam had some percentages marked and he had a scale marked, and it didn't seem to make a lot of sense. And Gleam goes on to say in his comment, here is the data table I gave you last time and it was fully explained to you. And then there is these are the headings for the data, and these are the data. And my response to Gleam is, I really don't remember ever looking at this data table. You may have sent it to me in a comment, but your comments have a tendency to be long and almost always completely wrong. It was already clear to me that your drawing was complete fantasy, so I may well have ignored your attempts to explain it. Apologies for that, but if you want something to be taken seriously, excuse my phone bleeping away there, if you want something to be taken seriously, it would help if you made just a little effort to get your figures and diagrams correct first. Here, Let me show you what I mean. So the data here in the table is a little bit unclear, difficult to understand in the comment section because it's not in boxes and it's not laid out in a spreadsheet type format. So I copied this data into a spreadsheet and examined it. So in black here is Gleam's data, mostly in black, and in red are some figures that I'll talk about. So we have observer distance, and Traprane law is obviously where the camera is, so the distance is 0. Fair enough. Hopetoun Monument at around about 8.2, 8.3 kilometers from the camera, so Gleam's got that number correct. Then we have Ben Lomond, which is rounded up 125 kilometers from the camera. And Gleam has entered the number 12,460 meters here. A factor of 10 out. And he's done the same for Ben Narnain and the same for Ben Eam. So he's used incorrect distance figures for these hills. Let's look at the height of the various objects. A Traprane law is not 210 meters as Gleam has used, it's 221 meters. And I state very clearly in my video that the camera is at 221 meters above sea level. He's put the Hopetoun Monument at 250 meters, but it is not, it's 210 meters. So I'm looking down from 221 to 210. The other heights, 974, 926 and 1011 meters for the 3 mountains, he's got correct. Now let's have a look at angular size. Gleam comes up with an angular size figure for the Hopetoun Monument of 1.344. I think this is meant to be degrees. He doesn't actually say. Now he's obviously using a figure of 250 meters, so he's using the wrong figure. The correct figure, using the appropriate formula, is 0.02539, etc. radians, which translates to 1.4548 degrees. So I'm not exactly sure, I haven't tried to work out how Gleam obtained this figure. The figure for angular size that he uses for Ben Lomond is not correct because he's used the wrong distance here. And the correct figure in degrees is 0.446, not 4.47 as he has indicated. The figure for Ben Narnain is 0.393, not 3.93. And for Ben Eam, the correct figure is 0.421, not 4.2. He's got 4.23, but close enough. So Gleam's used completely the wrong figures for the angular size of the objects in the picture. He gives a value for the horizon. This is the globe Earth value for the horizon, and for the degree of dip to the horizon in degrees. I haven't bothered to check those. I don't see the relevance. There isn't a horizon in the photograph. You simply see the landscape silhouetted against the sky. There's not a true flat horizon, and it's not possible to predict where the horizon actually is. The line that I've drawn across the screen, which you saw in the opening slide, is not meant to be a horizon. And that line is simply a line showing where 210 meters is at 8.2 kilometers from the camera. And so anything that is 210 meters or taller should appear above that line. That's the purpose of the line. It's not a horizon. Gleam's figures for the refracted drop are accurate for the Hope to Monument, fairly accurate. Again, he's probably used the wrong number here, but out by a large factor in terms of the other mountains. The refracted drop for Ben Lomond is over 1,000 meters. For Ben Narnain is over 1,200 meters, and also over 1,200 meters for Benim. And I don't know what the figures are supposed to be here, what the units are supposed to be, because he doesn't say so, doesn't mention it, but whatever they are, the relative amounts are way out. It goes from 4.63 meters for the Hope to Monument up to 1,260 meters for Benim, not 4.6 to 12.6. Then we come to the scaled distance in centimeters. So he says for distance 2 millimeters equals 1,000 meters or 1 kilometer. And I'm assuming that that's what he's referring to here for scaled distance. The scaled distance to the Hope to Monument is not 16.54 centimeters, as Gleam has stated here. It is 1.654 centimeters. He has got the scale distance correct for Ben Lomond and Ben Narnain and Benim. And the scaled height times 2, he has put at 500 for Hope to Monument, and it should be 420. Why he's multiplying the scaled height by 2, I'm not certain, but using a different vertical scale and a different horizontal scale is fine, as long as you make it clear that that's what you're doing. The scaled height figures for the mountains are indeed correct. Now, if we actually look at what Gleam has used in his picture, did he actually really use even these figures? I don't know for sure, but it doesn't appear that he did. Looking at Gleam's drawing here, we have the observer here and the Hope to Monument here. So let's assume that Gleam did use his incorrect figure of 16.54 centimeters. We know then that this distance is 16 centimeters, 16.54 centimeters, and the distance to Ben Lomond in his drawing would be 24, nearly 25 centimeters. So that looks as if that's what he's used. And then to Ben Narnain, a little bit further away. Now, why he hasn't put Benim in is beyond me, because Benim would only be a short distance further away here. It certainly wouldn't be off the page. If we go back to the spreadsheet, the difference in distance between Ben Narnain at just about 27 centimeters, it's only 0.4 of a centimeter. So there's no reason why he couldn't have fitted Benim on. But he has Hope to Monument in completely the wrong place. Hope to Monument should be just over 1.5 centimeters from Traprain Law. So the Hope to Monument should be right back here and not here. Now, what did Gleam do for the heights of the various objects? He states here he's used a scaled height, or there is a scaled height figure. He doesn't give a unit for that, so I've no idea whether this is what this is supposed to be. I'm assuming this is the actual scaled height doubled in meters. So he can't have used that because his drawing is not 2,000 meters tall. So I'm not sure what he's used here for the height. The angular size would be the correct kind of thing to use, perhaps, particularly if he was trying to give some sort of idea about how much things have changed in terms of angular size. But as we've already seen, his angular size values are completely incorrect. Certainly for the three mountains, out by at least a factor of 10. But where does he have in this spreadsheet a value for the height of the Hopeton monument that is 4 times higher than the value of the height for Ben Lomond? And where does he have a value for the height of Ben Lomond that is twice the height of Ben Narnain? Angular size for Ben Lomond and Ben Narnain are not very different. They are different, but they're not extremely different. And the value that he has is, the Hopeton monument is a quarter or thereabouts, between 3 times and 4 times smaller than Ben Lomond, and yet he has it represented in his picture as being much, much larger. So the Hopeton monument's in the wrong place, even by his own reckoning is wrong. But if he'd done the reckoning correctly, Hopeton monument should be here. It's impossible to work out, as far as I'm concerned, how he gets the heights of these mountains and the monument. It's impossible to work out how he calculated the angle for the apparent rise in the floor. And as you will see in the long version of this video, he has plucked these figures from a completely inappropriate source, given the way that my original picture was actually obtained. So Gleam, this picture really does prove that the Earth cannot be flat, and your attempt to explain how it could be possible on a flat Earth just doesn't make sense. You've got all the figures wrong, even if there were, and there is no validity to this kind of drawing, but even if there were some validity to it for this particular observation, you haven't even used the figures that you obtained, and the figures that you obtained are wrong. So with that, I will leave you with this picture. Thank you for watching, and there will be probably about an hour-long video coming out which will go through every single one of the points that Gleam has raised and deal with every single one of them. Earth is still not flat.